Now let's look at the PV function, the present value function. This function calculates the present value of a loan or an investment based on constant interest rate. The syntax for this is PV, then we have rate, NPER, PMT as required arguments, and PV and type are optional argument. So rate is the interest rate per period. NPER is total number of periods in an annuity. Then PMT is required argument. It is the payments made each period that cannot change over life of annuity. FV is an optional argument. This is the future value or the cash balance to be attained after the last payment is made. If FV is omitted, it is assumed to be 0. Then type argument is an optional argument. This is number 0 or 1 and indicates when payments are due. If omitted, it is assumed to be 0. 0 means if the payments are due at the end of period, and 1 means if the payments are due at the beginning of period. Now we need to again remember to use positive numbers for cash inflows and negative numbers for cash outflows. So let's look at the example. An investor plans to contribute 500 each month for 30 years with the payments made at the end of each month and an annual fixed rate of 8%. So calculate the present value of the investment. So rate of interest here is 8%. Then NPER, again he is contributing for 30 years each month, so it will be equal to 30 times 12. Okay. Payments, he is making contribution of 500 each month, so that will be minus 500 because that's a cash outflow. Future value is 0 and payment type is also 0, or we can leave it blank. So we'll just put it there. So present value, the function is equal to PV and rate. Rate is 8% and we need to divide this by 12 because of monthly payments. Then NPER is 360, that's already in months. Then contribution each month is minus 500, and then FE is 0, or we can just omit that and close the parenthesis and calculate. So we got the value of present value of 68,141.75.